Hello again and welcome back. In this lesson, I'm going to show you how to work with z-values in ArcGIS to create 3D feature classes. Now, this isn't an area that I'm particularly expert in, and so it's going to be one of the first in a set of lectures that we'll see throughout this class and the next class, where I'm showing you a concept that is possible in GIS, but I might not show it to you as much in depth, either because, like I said, I'm not a particular expert in this, or because we don't have enough time, or because it requires specific equipment that we don't have in an online distributed course like this. Still, it's valuable to cover these things because some of you will make connections to your own work that are valuable to have this skill for, and knowing that it exists, you can then go look up more information about how to use it and train yourself further than I can show you here. That's something you could do with any lecture in these courses, but it's particularly relevant in cases like this. So what is a z-value? A z-value is an analog to the x and y values. The x and y values help us specify locations in 2D space, and the z-value lets us add a third dimension to that by specifying the value in 3D space, along with the x and y values. Now, by default, our feature classes are only 2D. They store x and y coordinates. But we can make them 3D by specifying a vertical coordinate system. And again, we'll talk more about coordinate systems in a later part of this class, but for now, know that you need both your two-dimensional coordinate system and your third dimensions coordinate system in order to work with 3D data. So let's start by just creating a feature class that we can use for this. So I'll put in my default geodatabase, and you should know how to create feature classes by now. And the new feature class dialog will pop up, and I can give it a name like research points, and I'll select it as point features here. And then to make it 3D, down at the bottom here where it says geometry properties, I need to select coordinates include z-values used to store 3D data. And click next. Now I select my regular XY coordinate system as I usually do, and I'll leave it as the one that's selected right here, the contiguous albers for the USA. Click next. But then I get a similar thing next, which says choose the coordinate system that will be used for z coordinates in this data. And as you might expect, just like regular coordinate systems, it says vertical coordinate systems define the origin and linear unit of z-coordinates. They also define the positive direction of values in order to model heights or depths. So they're very similar to our x and y coordinate systems in that it defines an origin point and then what coordinates to use. But in this case, it's just for a single stream of values for the z-values. So in this case, I'm going to select one that's good for North America since it'll match the data that I already have, which is a North American optimized data set. And I'll select North American vertical datum of 1988, NAVD 1988. I'll click next. And then the rest of this is the same as it always is. I can add attributes. We'll just give it a name and click finish. Nothing too different. I just had to choose to enable z-values, and then I also chose to add a specific vertical datum, a specific vertical coordinate system. So it already added it to my table of contents for me. Just as with 2D data, the next thing we might want to do after creating it is edit it and create new features in it. And I can go to Editor, Start Editing, and I got no warnings because everything was set up. It's in the same coordinate system. And now maybe let's add a base map so we can see where we're working with. And I'll choose the imagery base map. And it comes in basically like an unwrapped cone because I'm using a conical projection. So let's zoom into an area that this is actually optimized for. Maybe we'll go to Sierra Nevada here. Let's zoom in down here and map some trees. And maybe the value of the z-value is actually the height of the top of the trees in meters. And if you're following along at home, you don't have to find the same trees I did, just find some trees and work with those. Now, with the editor, I can bring out my Create Features pane, and I have it here, but if you don't have it up already, you can go, as a reminder, to Editing Windows, Create Features, and that's what you want. And I'll click on Research Points. I'll just click Point here, and I'll put a point on top of a tree, and I'll put another point on top of another tree. But where are my z-values? That's what you'll be left wondering here. And to see them, I can go to Editor, and then Editing Window, Sketch Properties, and I don't see them yet. But if I take this tool here, the Edit tool, and I double click on one of these, so I get the Edit Vertices window popping up, I can see the X, Y, and Z values, and I could set that to maybe 15 meters. Maybe it's a moderately sized tree, and it's 15 meters tall. And then I could double click on the other one the same way, and set this one to 12 meters. Well, what if I want a different default other than 0? To do that, I can add a specific tool to my toolbar, sort of like we did with the pixel inspector. I can add another hidden tool. So to do that, I'll go to Customize Mode, and under Commands, I'll type in Current Z, and I'll drag that to my editor toolbar here. And whatever the Z value in here is the default Z value. So I'll make that 10 for now. And then every point that I add from here on with the feature creation will start with a value of 10. So maybe I create 3 points there. And if I go to Edit Sketch and take a look at them again, I can see that the Z value on those is in fact 10, as we specified. Okay, and then I'll save my edits and stop editing. Now, what if I wanted to do some 3D analysis? So all the analysis work that we've done so far has been in 2 dimensions. Well, there's a 3D Analyst toolbox specifically for things like this. And if I go to 3D Features, I see some analysis tools I can use to work with 3D feature classes. We can make a buffer in 3 dimensions. So we've done 2-dimensional buffers already, but now let's do one in 3 dimensions. So if I take my input features of my research points, and we'll buffer everything by 10 meters. And we'll leave the buffer quality as the default, and I'll click OK to run it. Runs in the corner as usual. And I get these sort of rendered spherical looking things that you can see have lines on them when I'm zoomed to the right level. And these are multi-patch features. And a multi-patch feature is basically something that puts together a bunch of patches to look like a 3-dimensional object. And it doesn't look a ton like it here, but when we get into working with ArcScene, we'll actually be able to see these things in 3D. So we'll take a look at various items in ArcScene, both tins and multi-patch items, soon. Okay, just to wrap this up, I want to point out a few other things we could do. We can check if something's inside of something else in 3D, whether things intersect in 3 dimensions. We can do the Near tool in 3D, Union, and a handful of other things. There's not a ton of 3D analysis, but this covers a lot of our use cases, really, at least when combined with our standard 2D analysis. 3D in ArcMap and ArcScene has always been kind of a little weird, but when you move into ArcGIS Pro, with the concepts that you build in ArcMap and ArcScene, it'll make a lot more sense and it'll feel a lot more integrated. Still, we can do all the things that we can do in Pro in ArcMap and ArcScene. It just requires more steps transitioning between the 2 pieces of software and getting used to the workflows. Okay, that's it for this lecture. In this lecture, I showed you how to create 3D enabled feature classes and then a few things involved in digitizing them, specifically using the current Z setting to set the default Z value, and then how to view and edit Z values after you've placed features. We also talked very briefly about multi-patch features and different 3D analysis tools that are available once you have 3D enabled features. I encourage you to look up more about this if this is relevant to your area of work. There's a whole lot there in terms of working specifically with 3D data, but it's not a core focus point of this specialization. Okay, see you next time.